The first and most common question can be, what is cloud computing and what are its key benefits? Well, the short answer is cloud computing is the delivery of computing services over the internet. Its key benefits include agility, location independence, multi-tenancy, scalability, accessibility, reliability, security, collaboration, automatic updates, and cost savings. But if someone asks you to elaborate a bit more, then you can say, cloud computing refers to the delivery of computing services over the internet. Instead of relying on local servers or personal devices to store and process data, cloud computing allows users to access resources and software applications hosted on remote servers. If we talk about the key benefits, one of the most talked about benefits is scalability, the advantage of easily scaling up or down resources based on demand that comes with cloud. This flexibility allows businesses to efficiently handle fluctuations in traffic, storage needs, and computational requirements. The next benefit that cloud providers offer is accessibility. Cloud services can be accessed from anywhere with an internet connection. This accessibility facilitates remote collaboration, enabling individuals and teams to work together seamlessly regardless of their physical location. Other than scalability and accessibility, the companies look out for reliability and availability too. And cloud service providers maintain robust infrastructure with multiple data centers, ensuring high levels of reliability and availability. Through redundant systems, backup mechanisms, and disaster recovery plans, they minimize downtime and data loss. With this comes the elasticity, that is dynamically adjusting resource allocation based on workload requirements. This elasticity ensures efficient resource utilization, resulting in optimal performance and responsiveness. In cloud computing, there are three primary service models. Next and most crucial reason for which people opt for cloud is security. Cloud service providers invest in advanced security measures to protect user data. They employ encryption, access controls, and regular security updates to mitigate potential vulnerabilities. Centralized data storage in the cloud can also offer better protection against physical device theft or failure. Cloud services foster more collaboration and productivity too. Cloud-based applications and services facilitate collaboration among teams by providing real-time document editing, file sharing, and communication tools. This enhances productivity and streamlines workflows. And automatic updates and maintenance is another important benefit of cloud platforms. Cloud service providers handle the maintenance and updates of the underlying infrastructure and software. This relieves users from the burden of managing hardware and software updates, ensuring access to the latest features and security patches. And all this comes in a cost-effective way. By eliminating the need for upfront infrastructure investments, cloud computing provides significant cost savings. Users can leverage the infrastructure provided by the cloud service provider and pay only for the resources they consume, optimizing costs. An example of cloud computing is using a cloud-based storage service like Dropbox or Google Drive to store and access files from any device with an internet connection. This eliminates the need for local storage and allows for seamless collaboration and file sharing among users. Next question can be, Can you explain the different service models in cloud computing? Provide examples of each. On that you can say, in cloud computing, there are three primary service models: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. Infrastructure as a service provides virtualized computing resources over the internet, including virtual machines, storage, and networking. Examples of IaaS include Amazon Web Services, AWS, Elastic Compute Cloud, EC2, and Microsoft Azure Virtual Machines. Platform as a Service, PaaS, offers a platform for developers to build, deploy, and manage applications without the complexity of infrastructure management. It provides an environment that includes operating systems, development tools, and runtime frameworks. Google App Engine and Heroku are examples of PaaS platforms. And software as a service delivers fully functional software applications over the internet, typically on a subscription basis. Users can access and use the software without the need for installation or management. Examples of SaaS include Salesforce for customer relationship management, CRM, and Microsoft Office 365 for productivity and collaboration tools. These service models provide different levels of abstraction and cater to various user requirements, offering flexibility and convenience in leveraging cloud computing resources. Then they can ask, what is the difference between public, private, and hybrid clouds? So, the difference between public, private, and hybrid clouds lies in their ownership, infrastructure, and deployment models. A public cloud is owned and operated by a third-party cloud service provider. It offers computing resources and services to multiple organizations or individuals over the internet. Examples include Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform. A private cloud is dedicated to a single organization and is either owned and managed internally or by a third-party provider. It offers greater control, security, and customization options. Private clouds can be hosted on-premises or in a data center. Examples include VMware vSphere and OpenStack. And a hybrid cloud is a combination of public and private clouds, allowing organizations to leverage the benefits of both. It enables seamless integration and data mobility between public and private environments, providing flexibility, scalability, and cost optimization. Organizations can use the public cloud for non-sensitive data and applications while keeping critical workloads on the private cloud. And you can also add that some companies, in addition, also use a variety of public cloud services to support the different developer and business units, called a multi-cloud environment. So multi-cloud refers to the use of multiple cloud computing platforms or services from different cloud service providers. It involves distributing workloads, applications, and data across multiple cloud environments, rather than relying on a single cloud provider. Organizations adopt a multi-cloud strategy to leverage the strengths of different cloud platforms, avoid vendor lock-in, enhance resilience, and optimize performance, cost, and security. And by utilizing multiple cloud platforms, companies gain more flexibility, redundancy, and the ability to choose the most appropriate cloud services for their specific needs, depending upon different scenarios and use cases. The next question can be, how do you ensure the security of data in the cloud? On that one can answer, ensuring the security of data in the cloud involves implementing various measures and best practices. Some common things that we consider are data encryption. Encrypt sensitive data both at rest and in transit. Use strong encryption algorithms and ensure proper key management practices are in place. Access controls. Implement robust access controls to restrict unauthorized access to data. Utilize strong authentication mechanisms, such as multi-factor authentication, and assign appropriate user roles and permissions. Regular security updates. Keep all software and systems up to date with the latest security patches. Cloud service providers often handle infrastructure security, but users must ensure their applications and configurations are also updated regularly. Next, we can have data segregation, that is ensuring logical and physical separation of data between different users or organizations in a multi-tenant environment. For that, we can use virtual private clouds or dedicated instances to isolate sensitive data. We must work on backup and disaster recovery, implementing regular data backups and establishing a comprehensive disaster recovery plan is crucial. We can also use security monitoring and logging. We must employ security monitoring tools and mechanisms to detect and respond to potential threats. Enabling logging and monitoring of critical events and analyzing logs to identify any security incidents or anomalies is a must. And then we can go for routine options like compliance and auditing, that is understanding and adhering to relevant regulatory requirements and industry standards. A company must regularly audit and assess security controls to identify and address any vulnerabilities or compliance gaps. And at the same time, employee awareness and training is important too. A company leveraging cloud services must provide security awareness training to employees to educate them about best practices, security policies, and potential threats. Encourage safe data handling and reporting of any security incidents promptly. If using third-party cloud services, conduct a thorough evaluation of the cloud service provider's security measures, certifications, and compliance records. Ensure the provider meets your organization's security requirements. Develop an incident response plan outlining procedures to handle and mitigate security incidents effectively. Establish communication channels and responsibilities to address incidents promptly. And finally, it is crucial to remember that security in the cloud is a shared responsibility between the cloud service provider and the user. By implementing a comprehensive security strategy and staying vigilant, organizations can help protect their data and maintain a secure cloud environment. Next question can be, what are the key components of a cloud architecture? This question can be asked in different ways, like describe the cloud computing architecture, describe how cloud architecture works, or explain the cloud computing architecture, and so on. One can say that cloud computing architecture brings together two components of cloud computing, the front end and the back end. No matter what the requirements of the particular constituent are, it is important to bring the right type of services together that can support both internal and external users. So some of the key components of a cloud architecture typically includes the following. Front-end client devices. These are the devices used by users to access cloud services and applications, such as desktop computers, laptops, smartphones, or tablets. They connect to the cloud infrastructure through the internet or private networks. Backend cloud infrastructure. The backend consists of servers, storage systems, and networks that form the underlying infrastructure of the cloud. It includes data centers, virtualization technology, networking equipment, and hardware resources managed by the cloud service provider. Virtualization. Virtualization enables the creation of virtual instances of computing resources, such as virtual machines, VMs, or containers. It allows for resource allocation, isolation, and management, enabling efficient utilization of physical infrastructure. Storage. Cloud storage provides scalable and flexible storage solutions for user data. It includes various storage options like object storage, block storage, and file storage, depending on the specific requirements of the applications and services. Networking. Cloud networking components facilitate the connectivity between different cloud resources, both within the cloud infrastructure and with external networks. This includes routers, switches, load balancers, firewalls, and virtual private networks, VPNs, to ensure secure and reliable data transfer. Middleware. Middleware components provide essential services and functionalities to enable communication and integration between various cloud-based applications, services, and databases. It includes message queues, application servers, and APIs that facilitate data exchange and interoperability. Management tools. Cloud management tools and platforms allow administrators and users to monitor, provision, configure, and manage cloud resources. They provide interfaces for resource allocation, performance monitoring, security management, and billing. Security. Cloud security components focus on protecting data, applications, and infrastructure from unauthorized access, breaches, and vulnerabilities. This includes authentication mechanisms, encryption, access controls, security monitoring, and incident response systems. Service-oriented architecture. SOA cloud architectures often adopt a service-oriented approach, where applications and services are designed as independent modules or microservices. This allows for scalability, flexibility, and modular development and deployment. APIs and standards. Application programming interfaces, APIs, enable interaction and integration between different cloud services and applications. Adherence to industry standards and protocols ensures compatibility and interoperability between different cloud environments. These components work together to provide the foundation for cloud computing, enabling users to access, deploy, and manage their applications, services, and data in a flexible, scalable, and efficient manner.